Okay, what I want to look at here is something called center of mass, and it's like an average position for a mass. And what I want to do is start with a simple situation where we've got two masses, one like this and one like this. Now if we've got a distance between them, then what we're trying to figure out is what their actual center of mass is. We'll call the distance d. So this is the distance between the two masses. Now what does a center of mass means? What it basically means is that if you were able to put all this mass, if this one was 4 kgs and this one was 10 kgs, it's basically saying if you could put all this mass in one location, what would that location be? What meaning does that really have? It's a little bit like the situation we had in year 12 where we were talking about torque. Now if we define a point here and we said that was the center of mass, then if we looked at it from a torque point of view, it would be going this mass multiplied by this little distance here, we'll call it x, and then we'd have a look at this little point here and we'd say that mass times this distance, x2 if you like. And the center of mass is where those will balance. So you can think of the center of mass as a little bit like a point at which the torques balance. So from that point of view, when you've got two masses and you've got gravity acting on them, that's where you can actually say, well, the center of mass will behave as if the mass was all at that point, even though it might be spread around into 100 different little pieces. This will have some important implications, but for now, let's just have a think about how do we calculate that then. This is where we do a very similar thing to what we did with the torques. So we've got our two masses here. We'll call this mass 1, we'll call this mass 2, we'll call this distance d as we said, and we'll pretend we know where the center of mass, since that's the bigger mass, it doesn't matter which one is, but say that was the center of mass. You've always got to determine when you're doing these type of things, where do you measure from, and it doesn't matter as long as you know where that point is from. So I'm going to measure from this point here. So if my position or my distance to the center of mass is x, then to make these torques balance, then I would have to say that m1 times x, all right, must be equal to m2 times d minus x, which is this distance here, times d minus x. What we're trying to do here is solve for the center of mass. So if we have a little look at that, let's see what we find out. So if we do that, we can say, oh, okay, we've got two x's here. Let's just do where we want the x's both on that side, right? So let's go m2d minus m, the minus brings out minus m2x, m1x. So we can do, sorry, I forgot to put the 2 there. We can bring this onto the other side and just say m1x plus m2x equals m2d. Bring those x into m1 plus m2 equals m2d. Bring it onto that side and we've got m1 plus m2. So that's where we get that formula. This is the formula that you should try and remember, but you can invent it at the time. X is now our position for a center of mass. So if we do our little example there, let's do our example where we've got a 10 and a 4. We've got the 10 and the 4, and they're by a distance of, let's say 2 meters. No, let's say 4 meters is that distance. What we're saying is that x will be equal to m2d, m2 being the 4, times 4, which is 16, all over m1 plus m2, which was 14. So that's 1 and 2/14, or 1 and a 7th meters from here. And look, does that make sense? Well, if it was 2 meters, then that would be stupid, because you'd basically be saying that the 4 and the 10 were equal distance from the center of mass. The bigger the mass, the closer the center of mass is going to be to it. So 1 and a little bit meters is going to be about there. Makes sense. Always check your answers like that. So these examples with just 2 items, reasonably easy to find center of mass.